I think this is intended to be a provocation session in the sense that we were going to show you our tool for doing intermodal walkshed access and ask for some of the potential use cases that you might be interested in doing. So having already watched the wonderful previous presentation on routability across different modes of travel, while we're troubleshooting here with a screen, I'm going to open it up for use cases that folks are thinking about. I know Taryn left from KCM, but she had brought up a really important use case, which is, we know, even if we now have all the data about the 160,000 missing curb ramps, how do we prioritize across these opportunities for improvement? So that's one of the things we're going to try to address in this presentation. But what are some other use cases? SDOT had previously asked us to help optimize the locations of their disability parking placard spots so that they can optimize the walksheds and access to public buildings in downtown Seattle. As mentioned earlier by Jeff, downtown Seattle is somewhat challenging because of the topographical challenges there. We have a lot of hills. Getting across town is not super simple, and especially when indoor facilities are closed, meaning when public buildings are closed and you can't use the indoor elevators to elevate from 2nd Avenue to 3rd, for example. It's much harder to travel downtown, and so using those parking disability placard spots to identify where people have access and reach if they park using those facilities, and are there any public buildings that are inaccessible as a consequence of where these locations are. So these are some of the analytics that we are currently doing.
Spaces from the others, so we can tell the difference, because I never know if there's a van space available. Does that make sense?
It makes perfect sense. So the question, just for those on Zoom, are there ways to tag certain spots as van accessible versus others? And for those who are unaware, when it's van accessible, it means that there's space for ramps to deploy in addition to other in addition to being proximal to facilities, whereas if it's a typical disability spot, it might just be close to a location, but may not allow people to have the parking aisle and space that's necessary to deploy a ramp. So the answer to that is going back to what we talked about, data schemas. So when we add data in much more specific ways, it allows people on the other side to interpret that data in these. So the idea that came up earlier, actually, even in the ODOT conversation, was about having data schemas that allow for downstream interpretation that is very locally specific, so that regional elements can be incorporated into these data sets. One of the things that we've really focused on with OS Connect is that flexibility. So there's the core baseline data, but there's the flexibility to regionally add extensions to that are specific to an agency's information. The King County Metro example is one such example. They have very specific local and agency-specific ideas and details and extensions to the data, and that's structured into that form that they were showing. And so anybody can flexibly raise these distinctions across different types of elements, so making sure that they tag a disability spot as typical disability spot versus van is one such example. So we have the capability to do that. The next question is, who's going to collect that data reliably? And that's sort of the question we want to partner on answering tomorrow. Well, at least raising the question. I don't know about answering it. So the idea is, let's get you you, the collective you, identifying a project that can add or suggest enhancement to the OS Connect data by way of identifying specific tags that you want on there or specific extensions. We saw in the demonstration that was brought up earlier that one of the extensions we added to the data is width confidence. That's a confidence metric on what we put in as the width measurement for the sidewalk. So that was a local extension that we opted to put in because actually of the question that Mary brought up earlier. I think that the answer to your question, Mary, previously is how, in terms of how to distinguish between potential data issues versus actual discontinuities on the public right-of-way. Given that none of this data came about based on reference data, there was no reference. We didn't start out with a gold truth that we were comparing against. Our models produce a confidence metric on the predictions, and presently all the predictions were vetted by hand using those human AI tools, but we kept those quality metrics, and that's something that we could report as part of those QA/QC reports. However, the traversability metric is not going to be, so I would say that taking together the low traversability alongside with low confidence is where we're going to put these hotspots to identify where you ought to go check the data because it's less likely to be accurate. And in particular, those hotspots that were identified, I think in one of our last question slides in terms of, where are the 20 or top 50 intersections that you might want to go to check. That's what that was trying to convey based on this thing that I'm about to show. So let's talk a little bit more about that. We talked about the importance of connectivity, both in terms of identifying where can people walk, where can people access transit, where can people access transit and then access other communities where points of interest and services might be available. And all of that has to do with basically simulating folks on our integrated transportation systems. So Thomas and Kurt showed us one methodology that they were using in order to integrate routes, roads, as well as the sidewalk routes. The next step, as they mentioned too, would be to integrate some transit information as well so that we can really understand much better where do people have access and reach. But being able to simulate those folks on the public right-of-way requires a little bit better routability than what we have traditionally been accustomed to, in the sense that, are we there? Oh, great. Well, almost. So the current router that we use allows us to do flexible costing. What that means is if you think about the penalty that each of us incurs when we walk down a specific sidewalk, meaning when I go uphill, if it's an 8% hill, I'm still okay, but at 11%, I take a certain hit. And over time, that penalty increases because I've been walking for 4 miles uphill and now I'm tired. So being able to model that in the router is kind of the thing that we're focused on, because as mentioned earlier, there's some variability across different types of users, and we want to be able to represent that. And in particular, we don't want to pre-bake that penalty or cost because we don't know always what types of users might be represented or modeled in different types of analyses. In the chat earlier when we were talking, David Miller, who's an O&M specialist for Lighthouse for the Blind, mentioned that people have multiple disabilities, and so you might want to be able to model those types of users. Perhaps not in the statewide accountability for access to job places, but certainly in some of the analyses that we want to show, we want to be able to represent multiple types of limitations or constraints on what the walkshed might show. And so the open source router that we use, comparable to what R5 was doing, is called Unweaver. And the idea there is that you do this kind of computation on the fly, on the, also like Anson mentioned, on the edge device. So right now, this computation has taken place on this computer, which is perhaps why that computer didn't want to participate with us. Great, thank you. And so the theory here is a map is nothing without considering who is using it, in the sense that nothing is static about the environment. It's all with consideration to who the user might be. And so if I want to model a particular type of user in this particular scenario, I get a chance to talk about, well, are they street avoidant at 1? And of course, we can make these a little bit more obvious. But as my street avoidance factor reduces, now I am modeled as potentially taking some roads that do not have streets, do not have sidewalk coverage, but maybe I'm willing to do that once in a while. So, and as I reduce my avoidance factor, a lot more of the roadway becomes available to me, as well as those situations where it will tell me, yeah, you're gonna go down a street without a sidewalk, but you said you're okay with that. That's essentially what we're trying to model here. And so, likewise, with other types of choices, we can avoid raised curbs and stairs. So if I remove that avoidance, well, in this case, Seattle's downtown is pretty well covered with these curb ramps, and so nothing changed in this particular example. But let's say I know First Hill has less coverage. Let's go here. What's that? Oh, thank you, yeah. So if I calculate a walkshed here, you see that as soon as I turn on the avoidance of, actually not that bad. Go Seattle, okay. The point being that if we want to make these very specific distinctions and allocations of where a person might have access and reach, we're able to model these different types of pedestrians. Now, does everybody care about this level of flexibility and local visibility? Perhaps not. But in many of the types of analyses that we do, we might have we might opt for having that because historically we might have modeled particular types of pedestrians. Now, the other part of this type of analysis is the cost. So I talked a little bit about the penalty that I incur when I walk around. Different people have different types of costs. And so being able, oh, wow, okay. So in that particular case, I increased my cost allowance from 300 seconds, meaning 5 minutes, to 1,200 seconds. And consequently, I see a much wider access walkshed that I might have access to. Now, I'm still avoiding raised curbs in this particular situation, but my street avoidance factor is pretty low. Let's go back to the scenario where I refuse to go down streets that do not have sidewalks. Takes a little minute there. Again, I'm impressed with this level of reach. The other part that this tool is able to do is provide me with the information about what is that access and reach. How many footways am I using? How many sidewalks? Let's reduce this number again so that I don't have so many. I'm gonna go back to 300 seconds, so 5 minutes of reach. Now I have 73 crossings in my way, a number of 32 pedestrian roadways, marked crossings, etc. And this particular data set, going back to the example, is about integrating into it public amenities in public buildings. So we try to capture in these types of analyses where public buildings are and whether I have reach to those facilities through this particular, like my starting point is where A is annotated, and within that 5 minutes of reach, I have access to the administration building, for example. And I'll also get some level of understanding of, like, I'll have benches along the way and some bollards, street lamps, etc. The other thing that this tool allows for is, yeah.
I saw waste baskets. How come there are bathrooms?
Can you put them in there? Would you?
Can you put a place for me to put them in there?
Yeah. No, that's the whole point. The whole point is in engaging folks and telling us what do you want to see in there so that we can adequately assess, access and reach to different types of amenities. I think we definitely need power sources for chairs. That's a conversation that we've had before. Anyone else? Yes.
I want running trails. Description of running trails.
Descriptions of running trails. That's I need to wink at Grace a little bit for that one. Anyone else?
Levels of traffic stress.
Great question. Okay, so levels of traffic stress, that's a great thing. So we want, in addition to having the roads here, which they are integrated in here, we need to have the proximity of the pedestrian to that said road and what level of exposure that pedestrian might have to 35 miles per hour traffic. Also, the difference between like the actual speeds on those roads versus the max speed posted is also an important distinction. So those are the types of things that we want to better understand what type of data people would actually believe as level of traffic stress. But that's, something that we are interested in pursuing. We did do an analysis specific to Bellevue schools. So that was limited to the 10-minute walkshed across 4 different schools. You'll see one of those examples in a minute. And there, Bellevue got to define how they define stress so that we were able to calculate it. I think part of the difficulty in doing these types of analytics is the definitions are so highly varied. So that's something that Thomas alluded to, right? Like, we don't even have agreement on what is frequent transit, what is traffic stress, because we've never seen this data before, and a lot of the times people might have disputes over, like, what is that definitional distinction before we even produce these analytics. Yeah, please.
We have a comment in the Zoom chat from Sonatina Sanchez. I'd like to know about overhangs I can rest under and things that might hit my head, like overhead wires.
Love it. Connected to other comments we've heard before about vegetation and overhang vegetation. I see Jeff.
Yeah, this is a dicey area. I was involved in it before with another implementation, but is there a way to track low crime areas or high crime areas and route yourself around those? I know it is. It's dicey.
No, so I have a sort of answer. The idea with the tool sets that we present here is that you get to integrate your own layer. What I want to show in particular, when I use the settings tool, I not only get to choose what data set I want to use in this router, but I also get to search the extension data sets, which means anybody can upload their favorite data set and we don't have to expose it to the world. But in that case, you get to sort of define what you consider to be high crime, who got to define that data, how that data came about. That's all within the business of the user. You know, these are things that we wouldn't necessarily go publish, but it's available there for use. Yeah.
This is a, excuse me, this is a partial answer to the other Jeff's question, but I wonder if there's a way you could have points that represent businesses and their opening hours, so I could be routed preferentially down streets that are open, have more businesses that are open, which might make for a safer experience walking down that street at night.
So that's actually been in Access Map in one form or another since 2018. Because Doreen Cornwell told us back then that her routing through downtown Seattle is completely integrated into what's open and allows her to traverse indoors. So, so we have the schema to capture that. Is that data up to date? Not always. But at least we have the ability to integrate that into this particular Unweaver router where, did we keep that in those options here? I think, oh yeah. So you can see that the trip option allows you to specify the time and date that the trip is taking place. And that's how we would integrate the information around opening hours. Okay, so I stole the floor, and I'm going to give it back to Sai. Sai is going to show us a couple of these scenarios, and then we can go back to ideating over.
It's okay.
No.
Thank you, Anat. I'll be really fast. I have like 5 or 10 minutes. All right. So, making access visible. Oftentimes, accessibility is, people don't notice it when it works. It's invisible, so to speak. But unfortunately, accessibility problems are also invisible a lot of the time. And we at TCAT really hate invisible accessibility problems. Well, because you know, if it's invisible, if you can't see it, you can't fix it. And you can't, if people don't see it, you can't ask for money to fix it. So the tool that we looked at is designed to help us find some scenarios that would otherwise be hard to see to make these accessibility problems something that you can show people visually and make a case for. Our first video here is the tool that we've loaded up here with the town of North Bend, and we want to take a look at the urgent care clinic in this town. And you know, if it's urgent care, you want to get there pretty fast, so within 10 minutes, hopefully. So we set ourselves a 10-minute walkshed to our urgent care clinic. And we can see that the north side of this walkshed is a little bit flat. So just visually looking at it, we can see that instead of a full circle like a walkshed would often make, the top part of this circle is flat. And that gives us a hint that there's an accessibility problem that we can go and look for. So as we look around the map, we can zoom in and we see that, hey, there's a set of crossings here that don't have curb ramps. And the tool lets us adjust these in real time to try out different accessibility scenarios. So now we've adjusted this curb ramp, this crossing to have curb ramps. and we'll regenerate the walkshed to look at the impact that it has on travel for these users. So, go ahead.
Sorry, so this goes to Kevin's question of storytelling. This story actually came from Rarat's experience recently with floods, that folks were unable to leave urgent care facilities and required NEMT assistance to leave it. And so in this particular scenario, some resilience building in the community would allow us to map the access to and from this facility, identify that story of where things break down, and identify where we could have a project and see whether that project, let's say adding a sidewalk and a curb ramp, would actually improve situations. I thought you were, go ahead, sorry.
Oh, that's okay.
Stop it.
So, yeah, we've applied the new expanded walkshed, and since we saved the first one, we can visually compare them now by overlaying them on top of each other. And we can see that just by adding a single curb ramp, the 10-minute range to this urgent care clinic has expanded by several blocks. All right, I'm going fast, so if you want to interrupt and let me know. So the second one here, again, in North Bend, there are several accessibility islands in the town. There's some older residential housing there to the south. There's a downtown area, some other businesses, a brand new townhouse development there at A with some very shiny new sidewalks that, as of now, don't go anywhere. And we can save all of these in the tool to visualize our accessibility islands on the map. And we'll pull them all up here, all in tandem. And we can see which parts of this town are disconnected. So again, small changes can have a big impact. We're going to go and look at another crossing that's also...
I'm just going to put a plug in here. If you're in North Bend, anybody can take North Bend's Snoqualmie Valley Transportation. It's not eligibility restricted. Anyone can get door-to-door service. You call, maybe Oliver will come pick you up within 10 or 15 minutes. Lovely service. So
awesome.
Everyone takes Snoqualmie Valley Transportation.
Sorry,
Thank you.
question?
Yes, sir.
When you're defining thank you. When you're defining those walksheds, is there like a maximum time distance on those walksheds, or did the walkshed just extend until it met a barrier, infinite hypothetical
For
distance?
this example, I did give it a huge cost budget, so it would run all the way up until that barrier.
Right, cool.
So,
Thank you.
Or the edge of the network that's available.
Appreciate it.
So here we have another crossing, and no curb ramps again. If we fix this one crossing and save that in real time so we can try out this new scenario here. I have my two accessibility islands, orange downtown and red or pink as this residential neighborhood. And if I regenerate that walkshed in blue now, I can see that we have now crossed the two islands. We've joined these two islands together, and both of them can reach each other there in the center, where they have a bunch of POIs, an outlet mall, and lots of amenities for people to get to. Okay, we're moving on here to Bellevue Public Schools. I think you wanted to talk about these. All right, we have two middle schools in Bellevue, and we're looking at a walk versus a roll comparison here. Blue is the rolling walkshed, and pink is the walking walkshed, and we can see that the walking walkshed extends. I'm sorry, I should say unconstrained walkshed. It extends quite a bit further. And the tool allows us to review statistics about walksheds that we generate. So if we look at the numbers here, and I'll show a slide with these after we look at these screenshots, we can use these statistics to kind of create some metrics that we want to track. Our second middle school is Highland. Again, we can see green is our unconstrained and purple is our rolling walkshed. And here we look at the two schools. They're actually pretty close geographically. We can see them side by side, and we can take a look and say, hey, the walkshed on for this school is not as good as the walkshed for this one down here. Visually, the ratios are certainly better on the south end, and we know that if we want to focus resources on one of these two schools, we can focus it on the one that needs a better walkshed improvement. Do you want to talk about this slide? I didn't have anything for this one.
Okay, so this is really just a summary. How can you do this at home is the point. Can we talk about the potential numerous locations that you might want to assess? So this might be a suggested new bus route. Where do we place the stops? Or, in order to maximize not just the population served by as the crow flies analyses, but actual access and reach to those stops. We might use, these comparative school analytics or grocery store access, different types of locations within proximity and reach. The way that we've been using these are also, going back to the King County Metro Health Through Housing approach, these 15 facilities that incorporate transitional housing for different people. What kind of access and reach are they allowing people who are trying to transition back into community life? What kind of access and reach do they have there? And can we put a comparative metric on those things? So somebody being, placed in Salmonberry in downtown Seattle versus someone in the Redmond facility, what is their comparative access to transit? What is their comparative access to other kinds of services, grocery stores, et cetera? And in particular, a lot of these, people who are being transitioned into those homes, they have different disabilities, different access needs to medical clinics and health facilities, and we need to be able to model that in order to provide them with the most successful outcomes. So the idea is, can we do this at scale in different types of scenarios while still using approximately the same kind of tooling, but giving people the flexibility to add in the kind of information that we were just talking about that would provide you with the analytic flexibility to really model what you're trying to do, as opposed to something that is just approximate or an estimate. So again, this is about a provocation of what are some of these scenarios that you can think of that we've just been overly constrained by our tooling not to even expand our ideas into those kinds of analyses, but can you think of the specific scenario you might want to model in order to understand comparisons, and also, like we said, project ideas to be able to model the project outcomes, and prioritization that Taryn talked about. We can now kind of talk more about, well, I want to really prioritize every bus stop having 10-minute walk reach to fresh groceries, something like that. Go ahead.
Oh, I was just curious with the Snoqualmie Valley, you presented to the city councils or the mayors or the policymakers about this information post the flood?
Post the flood?
Yeah.
No. How does it come? Oh, the question was whether we've presented to Snoqualmie Valley post the floods. But I gave Dean my slides. That's as good as we go. Okay, so the idea is the pipeline is just 4 steps. Save the baseline scenario, whatever you consider to be baseline, for 1 or more locations. Then you adjust the parameters to identify what comparisons you're trying to make, and then save that scenario B for the same 1 or more locations. And then compare coverage, metrics, assessing relative reach in each one of those vicinities. Now, in the future, and Paolo is hoping very near future, we want to bake a specific score to that access, that which you're calling the freedom to access and reach. It's the access to a basket of goods. And I think, again, this goes to what do we define as the necessary basket of goods? But for now, we're trying to allow people to have as much flexibility to try different things with the tool so that we can see what people really want to understand about access and reach in the public right-of-way and the connected network. So this is, again, going back to that schools example, pulling those 2 middle schools, we're looking at what are the 2 different scenarios between an unconstrained walking student and a rolling student. I should say the unconstrained student modeled in this scenario is not allowed to walk down streets that don't have sidewalks. So that's kind of the safety model that we have for them. And looking at that, we see that the 2 different schools have different levels of coverage across those 2 different subpopulations of potential students. But it's not that big of a difference. It used to be much bigger 4 years ago, so Bellevue's done a lot of work. And again, this goes back to being able to measure and demonstrate improvements in the public right-of-way. So, yeah.
Is there a use case maybe to help optimize crossing guards, perhaps? Like where to place them to allow the most access? Like to a school, from the most households to the school, like where you would want to place the crossing guards, maybe?
Yeah, so just to repeat the question in case it wasn't heard, the mic wasn't working. So is there a way to identify places where crossing guards might be helpful? So I think, if it were me and I don't do these kinds of things, I would probably look at, so I would add data, firstly, about visibility of curb bulbs and if there are larger curb bulbs in certain locations. I would add pedestrian lights and traffic signals to my analysis, and then I would look at the comparative metrics. I would also look at the centrality values, going back to the QA/QC scores of those intersections. And so high centrality, meaning that they convey across a lot of different locations, alongside with low visibility, high level of traffic stress or exposure to high speeds. Putting all those together, I would measure that in this tool and be able to identify those locations that give me the highest score if I'm penalizing for those types of things. Yeah.
I'm looking at our right-of-way owner friends in the room. And I don't really remember, I knew this at some point, but there is that whole kind of how a bill becomes a law process for how a complaint becomes a project. And that takes years for people saying, hey, this is all messed up, you got to fix it, or, oh my God, there's so much congestion here, build another bridge or whatever. And at every step along that way, it's like a fish ladder, right? There's fewer and fewer that are getting through, and it seems to me that it would be really easy for us to, and so there's a statewide transportation improvement program that kind of guides that progression, but each jurisdiction, each city has its own kind of fish ladder of things that are waiting to jump to the next level in terms of it's ready for, you know, this is a good idea, and now we're going to do a little bit of thinking and project development on it, and then it's going to go another step. We could easily put every single one of the projects that are currently in one of those fish ladder hoppers through this and give it a score. Right? Like tomorrow, like we could start and say, oh, this is a really stupid one. You know who I'm channeling, obviously, is Thomas. Say this particular project that's in your hopper has a lot of juice because people have been complaining about it for a long time. But in fact, it's not as useful as this other one that is gone under the radar. And I think that we could just do it in terms of putting every single one of the projects through it and giving it a score. Just like those people, the Transportation Institute of Texas come out once a year and say, hey, Seattle's got the worst congestion in everywhere. And then people get all excited and so that could be like a really good application of this, is just sort of develop a, you know, whatever, goodness score for every one of the projects that are
this is
under
hush,
consideration.
And people are not listening online, but we actually did this for Kitsap because they passed a specific change in the public right-of-ways that many in leadership thought were just unnecessary and unnecessarily expensive, and the trade-offs with other types of projects. So we were able to run those analyses for them. So really good point. And you know, part of it is we're not aware of all the things that are being compared across that fish ladder, and so.
Right, I mean, isn't there sort of a requirement for you to get to the next funding step? You have to, I'm looking at Grace, what is it, what's the fish ladder stop that you have to be at?
I think that there is a certain level of project that gets onto the STIPs, is what they're called, the State Transportation Improvement Program or something. But I'm sure there are other much smaller projects that don't get on those. Like, I don't think every, you know, ADA curb complaint would get on a STIP. That is not the scale of project. So there are lists, you're right, but there's not a comprehensive list that I know of. Maybe Thomas wants to chime in.
No, I mean, that's right, and that's one of the issues there is like how we conceive of a project and the political coalitions that are created to focus on a corridor or and define what a project is. And I mean, you're absolutely right, Paulo, that like we could just do it. I mean, we could just do a lot of things, you know, to be honest. I do talk like that in certain private contexts. In a context like this, I might, you know, frame things a little bit differently, because there's that fish ladder is, you know, is built, has been built over decades. It has the engagement of a lot of different people across the entire state, across the entire nation, because it's all intertwined. People have different levels of political engagement, and they're like, many of them want to do good things, right? And they're, you know, so I do think there's a need to strategize and also build the tactics to think about like what is the change management that has to happen over years in order to actually get to that scenario where we can in the future plug everything into a big system that calculates some really simple metrics and yet also has a feedback loop with community so that we're not just like building an AI supercomputer to make transportation decisions for us. That is probably not actually what we really want, even if it were really smart. So, you know, that's part of what our team here of Grace, Mary, and myself for the sidewalk data integration at WashDOT, and Kurt and I thinking about destination access analysis, and many other teams at different agencies around the state are thinking about is like, well, how do we build the internal coalitions that understand those processes and figure out, okay, we flip this switch and get into this room, and then flip that switch and get into that room in order to put information forward, you know, in 2032 or 2050, if we're lucky, that then creates that process. And so it's like, yes, we can just do it, but we have to just do a lot of iterative things along the way, practically speaking, to make it happen.
Any last? Yeah.
Yeah, I just have a much smaller brain question. So there's a lot of big brain stuff happening back there. So your demo and this tool, I mean, the obvious extension to me is like, can you just run like 1,000 random points and toggle on or off 1,000 random curb cuts and give me the priority list of here's where we should, you know, the highest impact to our walksheds?
Yes. Can you define the highest impact to you? What is the highest impact?
Well, yeah, I mean, just walkshed increased. I mean, then
Okay.
you could weight it by,
Yes,
you know,
absolutely.
yeah, walkshed from where or whatever. But
So an exhaustive search of all the curb ramp, all thousands. Yes, yeah, that's exactly
I
right.
mean, have you done that? Will you do that?
Oh, will I do that?
And
I would
send
love
the
to do
report
that.
to a local jurisdiction.
So we're just now getting to the point where we're joining the road network with the sidewalks, which I think is important for these types of analyses, but we have done it exhaustively in very small places like Yelm or Graham, or, you know, but I think now we're at the point where we're actually able to run this in larger jurisdictions. Last question, sorry.
I kind of comment in regards to that. We did actually, if you go back to the Walkshed tool, there is a batch tab now that allows you to upload a CSV file with all kind of different parameters. So yeah, you can upload probably like as many as you want, thousands of them, and we'll run them and show all the scenarios for you.
And there is an API, so if you're a developer, write a loop.
All right, thank you, Sai. We're gonna transition swiftly. We did take note of all these comments, and we'll send out, at least to everyone who registered, the sort of note taking and some responses to some.